the graph of f is shown below, let g of x be equal to the definite integral from 0 to x of f of t dt. Now at first when you see this, you're like, wow, this is strange. I have a function that is being defined by an integral, a definite integral, but one of its bounds are x. And you should just say, well, this is okay. A function can be defined any which way. And as we'll see, it's actually quite straightforward to evaluate this. So g of negative 2, and I'll do the negative 2 in a different color, g of negative 2, well, what we do is we take this expression right over here, this definite integral, and everywhere we see an x, we replace it with a negative 2. So this is going to be equal to the integral from 0 to x of, and I'll write x in a second, f of t dt. Well, x is now negative 2. This is now negative 2. And so how do we figure out what this is? Now, before we even look at this graph, you might say, okay, this is the region under, the area of the region under the graph y equals f of t between negative 2 and 0. But you have to be careful. Notice our upper bound here is actually a lower number than our lower bound right over here. So it will be nice to swap those bounds so we can truly view it as the area of the region under f of t above the t-axis between those two bounds. And so when you swap the bounds, this is going to be equal to negative definite integral from negative 2 to 0 of f of t dt. And now what we have right over here, what I'm squaring off in magenta, this is the area under the curve f between negative 2 and 0. So between negative 2 and 0. So that is this area right over here that we care about. Now, what is that going to be? Well, there's a bunch of different ways that you could do this. You could split it off into a square and a triangle. The area of this square right over here is 4. It's 2 by 2. And it's make sure you look at the units. Sometimes each square doesn't represent one square unit, but in this case it does. So that's 4. And then up here, this is half of 4, right? If it was all of this, that would be 4. This triangle is half of 4. So this is 2 right over there. Or you could view this as base times height times 1/2, which is going to be 2 times 2 times 1/2. And so this area right over here is 6. So this part is 6, but we can't forget that negative sign. So this is going to be equal to negative 6. And so g of negative 2 is negative 6.